Okay, so we're going to talk about what a rational function is. Okay, so these are rational functions. We've done the reciprocal function and the reciprocal squared function. They're in our toolkit. Those are both examples of rational functions, but there are other rational functions out there. So the definition, I'm going to give you my definition of a rational function. It's basically a polynomial divided by another polynomial. Okay, now in the notation, they say f of x is equal to p of x divided by q of x. And that's where p of x and q of x are polynomials, and q of x cannot equal 0, so we should state that someplace. Q of x cannot equal 0. Okay. They write this out. This is another way to show that. But you're going to have a sub p. Oh, that's not a p. Dang. Trying to use the notation the book uses. A sub p x to the p plus a sub p minus 1 x to the p minus 1. These are just polynomials, so they're going in that descending order, your greatest exponent first, standard general notation for a polynomial. And then you get down to a sub 1 x plus a sub 0 or a naught. And you don't have to have all those terms. In fact, we usually don't have, 15 terms up there, but you could. Okay. And then in the denominator, it's a different, those coefficients are all different. A sub p minus 1, and so on. And then they use b sub q, x to the q, plus b sub q minus 1, x to the q minus 1, plus dot, 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 plus b sub 1 x plus b naught, or b sub 0. So remember, the dots just show the pattern continues. So you have these terms in the polynomial, and then you're going to have a degree of the numerator. That polynomial has degree p, in this case, and that polynomial in the bottom is degree q. Okay, so you don't have to write it out that way, but I wanted to explain what the notation was a little bit. So basically, just remember, a rational function is a polynomial divided by another polynomial. And then we'll have some work with those.